exponential rise in plastic production, with its current use and management, is causing environmental challenges, from pollution of land and oceans to climate change. To address this issue, we need to change the linear life cycle of traditional petroleum-based plastics in our societies. This can be achieved through increased recycling and the use of biodegradable, renewable materials. Fortunately, solutions are on the way. Biopolyesters, also known as PHA polymers, show promise in reducing our reliance on non-renewable resources.
This technology is not only a way to treat organic waste, but also to produce a value-added product, bioplastics. For me, I've always been interested in environmental science. It saddens me that the current world is dependent so much on single-use plastics, and I wish to contribute to change. I'm Zarja Medved. I'm a chemical engineer here at Wetsus, working as a researcher of PHA bioplastics. Organic waste, such as food scraps, agricultural residues and wastewater sludge, can be used for production of PHAs. PHAs, or polyhydroxyalkanoates, are a group of polyesters. They are bioplastics and they are bio-based, biodegradable alternative to petroleum-based plastics. Here at Wetsus, Biopolymers from Water Research Team is focusing on PHA production as well as recovery and applications.
So first we have bacteria that can accumulate PHA in their cells. We call it PHA accumulating bacteria. And then we feed organic matters from waste streams to our bacteria. And the bacteria can convert those organic matters into valuable products, which is biopolymer, PHA.
But how does this work? The solvent and the rich biomass are poured and mixed together in an extraction reactor. We can closely examine what is going on during the process. The biomass consists of dried granules made up of many desiccated bacterial cells containing the PHA. During the process, the solvent mixture is heated. The solvent soaks into the granulate of biomass particles and the PHA polymers dissolve. Dissolved polymer diffuses out to make a dissolved PHA-rich solvent mixture. We have successfully extracted the PHA from the biomass. We just have to separate all the spent granulate of biomass particles from the PHA-rich solvent. A step of filtration readily separates the biomass and the PHA-rich solvent. Cooling of the solution of PHA-rich solvent results in a gel mass. This mass is a soft, semi-solid structure of solvent held in a 3D framework of semi-crystallized PHA polymers.
This PHA recovery process is developed with knowledge that can be applied to control the quality of the obtained polymer. So the challenge is not only to produce a larger amount of polymer, but to produce a polymer with defined and reproducible quality. Different steps during the recovery process determine the properties of the polymer. So the strength, the elasticity, which are all very important for applications. So PHA can be applied in many different fields. So in agriculture, medical field, as well as in packaging. In this developed process, nothing necessarily needs to go to waste. So the materials which are residues of the PHA recovery can be used as building blocks for other applications. There's possible to think of a future with no waste.